Jerry, I wasn't going to mention it, and you did plant it in my mind, but I have stood on that stage in a velvet bonnet, in a gold-braided gown, and shaken the hands of hundreds, probably thousands of local students, and what a joy to give them their degrees. I would also like to acknowledge, not by name, but the really esteemed people in this audience, but really by their institutional foresight. There are people in this room who 10 or more years ago saw this prospect that we're now on the verge of bringing to a reality way, way before I did. I've been deeply involved in thinking about hydrogen and to some extent leading the discussion about it. Is this working, by the way? You hear me at the back? Good. Leading the discussion about it for a year and a half to 2 years now. But as I look around the audience and I acknowledge you collectively, there are people here who had foresight that well precedes mine, and I think it's just stunning what you've been able to patiently achieve. I'm not going to try and describe to you what hydrogen is and why it's important. You've already heard a little bit about that. You will hear more about it during the day, and I know that Patrick will be covering that because we've discussed this. I want to talk to you about scale and diversity. I'm going to talk to you about the scale of the opportunity and how scary that is, but how it's actually opportunity. And I'll be using solar electricity and water electrolysis to give you a sense of the scale, not because I'm not interested in the coal hydrogen pathway, I'll come to that, but it's just easier to describe if I do that. Then I will describe what Jerry mentioned, which is the coexistence, the reason why I think that the coal-based hydrogen production is going to be an important part of our transition to a zero-emissions economy. And that's what I'm capturing with the word diversity. I'll talk a little bit about competition and then finish off by giving you a sense of where the national hydrogen strategy is at the moment. So I like to think on behalf of our children, myself as well, about our future, the planet that we love, but 100 years from now. I would like to hope that when we look back on that planet 100 years from now, it is still as magnificent as it is today. But as you know, there are threats to that vision, and the big threat is the greenhouse gas emissions. And those are what I've described as a global and a massive threat. And we're seeing more and more consequences of climate change all the time. But it's a big threat. I said to you, it's massive. So where do you start? Well, what I've got up there is a pie chart showing, I don't have current data, but it hasn't really changed, from 2013, the global, not Australian, but the global mix of sources for greenhouse gas emissions. And you can see it's entirely dominated by energy generation. Whatever the mix inside that big orange piece of the pie is, it's entirely dominated by energy generation. Energy generation is over 70%. Nearly 3/4 of our greenhouse gas emissions. So that's where we're going to get the biggest bang for the buck, the greatest return on investment. If we could break the back of greenhouse gas emissions from the energy sector, what a difference that would make to our future. We still have to deal with the others, but they're small in comparison. Okay, so we're going to start with a toolkit of things that we'll use to try to break the back of those greenhouse gas emissions, but our toolkit is restricted by realities. There are community realities and there are practical realities. Community concerns which say don't do this or don't do that. So let's look at the toolkit. There's the planet with a spanner on it. The toolkit of zero emissions solutions, so I'm not here talking about coal, oil or gas directly used for energy. The toolkit of zero emissions or very, very low emissions technologies. And if I say zero, please remember that when one's talking about emissions, zero doesn't have the same meaning as the mathematical definition of zero. It just means very low. That toolkit has got nuclear, new large scale, etc. Let's go through them one by one. Nuclear, it's just unpopular for whatever reasons. And whilst in some parts of the world it's still continuing or even being invested in, it's not the big go-forward opportunity that it was once conceived to be. New large-scale hydroelectricity. I'm not talking about pumped hydro. Pumped hydro, you hear a lot about it. That's not a form of energy generation, that's storage. Catchment hydro, We haven't built a new large-scale catchment hydro scheme in Australia for 50 or 60 years. And it's unlikely, in my opinion, that we will do one in the next several decades because of local objections. Biofuels, great, but, well, actually, they're not always great because you don't necessarily get a very good low emissions profile from biofuels. But even if you did, there's not enough land. So that's not going to be the solution. Geothermal, wave, and tidal, all wonderful, but after 30 or 40 years of effort, never have they shown an ability to scale up to the kinds of levels that will make a difference. So that leaves two. It leaves solar and it leaves wind. Two sources of energy going forward into a zero emissions future, walking away from a half a dozen to a dozen sources of energy that are powering the planet at the moment. Okay, but we can do a lot of solar, we can do a lot of wind. There is no limit to the amount of sun that we can tap into, but it's a big job. Sounds easy, it's not. So now take that 72% of the pie and now look at the breakup of that 72% of the pie. And what you'll see, if you can see over the table, I'll read out the bottom numbers there. The big orange piece is the oil, coal and gas. That's 81% of the energy that we use. And they're all fossil fuels with associated carbon dioxide byproducts. Then you've got other things we won't worry about. But right at the top, you'll see the little red piece of the pie. That piece there is the solar and wind cumulatively installed to the end of 2018. Now, you know we've been installing a lot of solar and wind, and many people will think, great, solar panel on my roof, battery in the basement, problem solved. It's not, because when you look at the total energy, I'm not just talking about electricity, but at the total global energy needs, of which electricity is only about a fifth or a sixth, the cumulative installation of solar and wind to date is only 1.2%, which means that if we want to replace that 81% of oil, coal and gas just with solar and wind, it is a massive effort. 70-fold increase on the cumulative installation, many hundreds of fold increase on the annual installation. That doesn't mean it's impossible. It doesn't mean it's impossible because we are looking at somewhat exponential growth in the rate of solar and wind installation. But it does mean it's big, really big. The scale is challenging, but that's opportunity. Jobs, capital infrastructure build out. It's a massive opportunity, but it's scarily big in the challenge. And to do it right, we need everything going for us. We need strategic commitment, storage and more storage. Long distance interconnectors, we need good digitalization and artificial intelligence for the utilization, and lots of other things all working for us. And it can be done, but it's a big challenge. And what we get from that, of course, is electricity. And electricity I often refer to being as almost magical in its properties because you can do so many things with electricity. You can run a heavy-duty, high-temperature industrial process, or you can power a cell phone. It's really quite incredible, but it's not always suitable for our needs. Sometimes we need what I call a high-density transportable energy carrier. Right? You need to have a big truck that will go from Melbourne to Brisbane without stopping. And you can't use wires, and batteries are unlikely to serve that need in the next 20 or 30 years. Or a ship that's going to carry 100,000 tonnes of iron ore from Port Hedland to Shanghai, it's hard for me to see that being powered by batteries. But there is an alternative, which is hydrogen, which is what we're here today to talk about. Hydrogen can serve the role of what you would otherwise do with petrol or diesel or compressed natural gas. It can be a high-density, high-energy, transportable fuel. How do you make it? There are two pathways for making hydrogen. I've got to point out, hydrogen is the most abundant element in the universe, without doubt. Over 90% of all the atoms in the universe are hydrogen, and it's very abundant on Earth. But nowhere on Earth is it available as pure hydrogen. It's bound up in some way or another. And of course, where it's bound up primarily is in water, H2O. H2O, that means two atoms of hydrogen, one atom of oxygen, that is your water molecule. Well, you can take electricity and pass it through water and crack the water. Crack it into its constituent hydrogen and oxygen, capture the hydrogen, let the oxygen go, that's okay. And that little diagram there is indicating 2 electrodes in water producing hydrogen and oxygen. That's called electrolysis. And that's where a lot of the focus on future production of hydrogen lies. But the other way is to start with a fossil fuel. To start with a fossil fuel, I won't go through the chemistry of it, although I will give you one chemistry slide in a moment. To start with a fossil fuel with CCS. And it's very important, we'll come back to that, because without the CCS, there's not going to be a market for this hydrogen fuel that comes from fossil fuels. So I've been thinking a lot about this. Occasionally I wake up at night, I think, oh my gosh. And the 2 things that really worry me, and that's me, if you're on the ceiling looking at me at night, the 2 things that really worry me, keep my eyes open, are scale and diversity. And I want to go through both of them in some degree of detail. So let's start with scale. And as I said, when I talk scale, if I talk scary, I'm also talking about opportunity, because there is opportunity to be derived from that huge challenge. So now I want you to imagine a world where Australia is exporting hydrogen at the same energy rate that we're exporting LNG. So Australia last year became the world's largest exporter of liquefied natural gas, LNG. So there's a lot of energy that we're exporting to customers around the world, very much in Asia. So let's imagine that we were using electrolysis for this example to make hydrogen, where the hydrogen had the same energy content as all that LNG that we're currently exporting. I'm not saying instead of, I'm just saying in addition, we're making hydrogen. Now, I have to have a couple of assumptions to do the exercise that I want to take you through. The first is that I'm just going to make everything from solar electricity. In reality, electrolysis will be done typically with a mixture of solar and wind electricity, or in Norway from hydroelectricity, and maybe even in Tasmania from hydroelectricity. In some countries, maybe it'll be done from nuclear electricity, although I've not heard of that being planned yet. But I'm going to do this exercise for simplicity as if it was all done from solar electricity with water. And I'm also going to just tell you that I'm not talking about a replacement industry here. I'm saying the reality is that worldwide demand is insatiable. Worldwide demand for energy is insatiable. It's going up by over 2% every year. And whether people are happy about this or not, most of that is being met by fossil fuels, by natural gas and by coal, and then by the renewables growth. But the demand for LNG, whether we like this or not, worldwide is likely to keep increasing for at least 2 decades and then hang in there for a while. So there is an opportunity for Australia to build a hydrogen export industry in addition. So we're going to take the pie of export and grow the pie rather than substitute. Okay, now I kept talking about energy equivalent because a kilogram of hydrogen, or what I've got there, an MT, a megaton, 1 million tonnes of hydrogen, is not the same in energy terms as 1 million tonnes of natural gas. In fact, hydrogen contains 2.4 times more energy for every tonne. So Australia exports 70 million tonnes of LNG, what we did in 2018, 70 million tonnes. The same energy could be done with 30 million tonnes of hydrogen. That doesn't make it easier, it just makes it different. Okay? So 30 million tonnes of hydrogen. To make that from solar, well, first, that 30 million tonnes has an embodied chemical energy. You can call it gigajoules, or you can call it terawatt hours. And if we're talking about electricity, the unit of energy is typically terawatt hours. So that bottle of 30 million tonnes of hydrogen for export has embodied chemical energy that we can reuse for transport or reuse somewhere else for generating electricity. That 30 megatons has 990 terawatt hours. But making hydrogen is inefficient, and you lose about 50% of the electricity in the process of cracking the water and then compressing the hydrogen and pipelining it to where you want. So if I assume a 50% losses, we need solar energy of double that. We need to produce 1,980 terawatt hours. Now, is there anybody in the room who has a feeling for whether that's a lot or a little? I'd be surprised. It's a lot. It's a lot. It's actually 8 times the whole electricity generation of Australia in a year. So forget the actual digits. It's 8 times the combination of the national electricity market on the East Coast, the South and the Western Australian electricity market, and the Northern Territory electricity market. They combined are 250 terawatt hours. So we talk about 8 times. So it's a lot of energy. Huge scale is my point. But huge scale is opportunity for investors. It's jobs, it's regional jobs, it's terrific. It's also a lot of land area, 18,000 square kilometres. That's a scarily big number, unless you look at it in terms of Anna Creek Station. It's 3/4 of one large cattle station. So it's a lot, but it's manageable. Okay, so that was just introducing you to the fact that the scale is big and demand is huge. I can't remember who said it in the early introductory remarks. It could have been you, Steve, but the Hydrogen Council has estimated that in 2050, worldwide demand for hydrogen will be a $2.5 trillion market. Trillion dollar market. And of that, about half will be the technology, the cars and the fuel cells and the generators, and half will actually be the trade in hydrogen fuel. So it's a huge opportunity. But remember I said all of that's got to, all of our primary energy is coming from solar and wind. And that in itself, if we're going to replace oil, coal and gas over 30, 40 or 50 years with solar and wind derived electricity, that's a big job. And then if we want to make hydrogen, we have to produce even more solar and wind electricity to make the hydrogen that will give us the transportable fuel. So it's a giant job. So let's think about diversity. We've only got 2 things at the moment. There's the list that I had before, and we already went through why the top 4 are not contributing. We're left with solar and wind. Well, what if there was a third primary energy source as opposed to just a battery? Well, hydrogen made from coal or natural gas has the potential to be a third primary energy source in the future where we are aiming for a low emissions energy economy. So you can start with coal or you can start with natural gas. They're both fossil fuels that can be used to make hydrogen, but it has to be done with carbon capture and storage. Because if you do it with carbon capture and storage, you can get a clean source of hydrogen and also a third form of primary energy, so therefore diversity of supply. So let me just talk about the importance of carbon capture and storage. So the HESC project that is being trialled here as a pilot at the moment isn't worrying about carbon dioxide emissions. They'll buy some offsets. But the reality is when you make hydrogen from a fossil fuel, you get a byproduct of carbon dioxide. And ultimately from about 2030 on, Japanese customers won't buy the hydrogen unless it's so-called carbon-free. Not mathematical zero, but carbon-free. So customers care, countries care, companies care. So there's the chemistry that I threatened you with. The C on the left, that is 1 atom of carbon. Coal, brown coal, is full of atoms of carbon. In a process called gasification and steam shift, you process that in limited oxygen with steam, with water, H2O, and out of it you get HH, that's the hydrogen that you want. You get CO2, that's the carbon dioxide that you don't want. You have to capture that carbon. You can't capture 100%, but you've got to capture a lot, 90, 95%, to make the whole process worthwhile. It's a big challenge. We've got some of the experts of the world here in this room, but they'll agree it's a big challenge, but it can be done. When you do that, you've got to capture it, so you take the carbon dioxide out of the equation and you're left with the hydrogen and you want to bottle the hydrogen. Well, I talked about starting with methane, natural gas. We can start with coal. We've got open cut pits here. The brown coal in the Latrobe Valley is a very, very low cost fuel, energy source to drive a process. You really wouldn't want to, from the economic point of view, be doing coal gasification starting with black coal because it's got a huge export dollar value, or starting with natural gas because it's got huge export value as natural gas. Brown coal doesn't have an export value. It's alluvial, it's on the surface, you can grab it and use it. But I've been trying to stress you need carbon capture and storage, and it's already been mentioned. The Victorian government has for at least 10 years been investing in a project called Carbon Net with support from the CO2 CRC, the Global CCS Institute, and Richard can give you the full details of that when he speaks. And it's really a scientifically sound project to identify how and where to bury the carbon dioxide waste. So that little red dot is to remind people, other than the people in this audience, where Gippsland is. And the Carbon Net project has identified a region called the Pelican site off the coast as a starting place, which has got deep saline formations, and they've very, very carefully analysed it. There is future potential to reuse depleted oil wells further north of that, but this is the starting position. And that carbon dioxide that went off the bottom of my previous slide will now come in the top of my next slide and be buried essentially forever. And that is the important thing. They have identified a site that is geologically stable, capped with heavy rock that's non-porous, and when the carbon dioxide goes down there, it will stay there. What do you do with the hydrogen? You've got to ship it. You want to send it to, well, we will use it domestically, but the excitement for this particular project in the Latrobe Valley and many others is to ship clean hydrogen to people in other countries that are not as well endowed with their own natural energy sources as is Australia. You can ship it by chemically converting it to ammonia. I won't go through the details, but you can. And then you can go out and rent a ship, because the ships that can carry ammonia are already there. The ideal way to ship it is to do a physical conversion from a gas to the liquid, just like we do with natural gas. You start off with natural gas as a gas, you liquefy it into LNG. If we can liquefy the hydrogen, we can ship it as liquefied hydrogen in its purest form. And that's what this project is looking at. Amongst the many partners, Kawasaki Heavy Industries is building at this moment the world's first large-scale, or maybe only, liquefied hydrogen carrier ship. And the idea is the hydrogen would be made here, go by pipeline to Hastings, where it would be liquefied and put onto a ship. And the sod turning or groundbreaking ceremony for that port in Hastings was about 3 weeks ago. And I and others were there. That I'm the third one from the left, doing this sod turning exercise for the Port of Hastings liquefied hydrogen export terminal. So things are happening. It's early, but happening. So I've just been talking about the Latrobe Valley project, the hydrogen energy supply chain project, which is intended to prove several things, but at the very least, the production and logistics. Can we do it cost effectively? And the hypothesis that coal generation is the cheapest form of hydrogen production in the near to medium term. I think that it may turn out that it will stay with solar and wind electricity a low-cost form of production for the long term as well. But it's more than just cost, it's adding to diversity, and people don't normally think about this. It's important to have diversity in an energy supply. So even if hydrogen from fossil fuels 30 or 40 years from now is slightly more expensive with CCS than hydrogen from solar or wind electricity, it still adds value to the system, and I think the world will want to have it as part of its energy supply. Because it's not just a cost issue. All right, if we can take that hydrogen from coal and natural gas with CCS, we get a third primary energy source, and that's important. Okay, now hydrogen the concept of hydrogen for fuel has been around for a long time, and some people who've been doing this for 20 or 30 years say, okay, Alan, come on, what's different this time? Well, it is different. In the first place, we've got countries who are determined to decarbonise. Japan is leading the world in strategic thinking about this. Japan doesn't have the solar and wind resources we do. They don't have the oil, coal and gas. Nuclear is not working out for them as previously intended. So they have strategically decided that they will start over the decades, not next year, but over the decades, they will start to replace their imported oil, coal and gas with clean hydrogen. So China gets it, California gets it, South Korea gets it. There is external worldwide demand growing. The second of three reasons it's different this time is the lower cost of production. If you look at renewables, 10, 15 years ago, it was inconceivable to make a cost-competitive hydrogen fuel from renewables. It's still too expensive, but the trajectory is very favourable. The CCS cost profile, because of carbon and also because of the nature of making hydrogen, is much more attractive than what you might have heard when you've heard about CCS for electricity production. People tend to groan if I talk about CCS, because with electricity production, it does add a lot to the dollar cost per megawatt hour. But CCS for hydrogen in a project like the one here in the Latrobe Valley is likely to be cost competitive and quite practical. So the costs of producing are good. And the third thing is the cost of utilisation is improving. That little picture there is a gadget called a fuel cell. And fuel cells will be used in all transportation vehicles, all hydrogen transportation vehicles, and also for stationary electricity generation, all sorts of things. Some examples. The world's taking it seriously. That is an on-the-road big truck that can take 40 tonnes of cargo 2,000 kilometres, Melbourne to Brisbane, running on hydrogen. If that was a battery-powered truck, and I'm not denigrating battery-powered vehicles, I drive a battery-powered car, but if that was a battery-powered truck, it would be carrying 40 tonnes of batteries just to get itself there, but without any cargo. In Germany, they're driving French trains from the company called Alstom back and forth in regular use now. That is a hydrogen-powered train. In Japan, there are thousands of hydrogen cars on the road, and I saw a Toyota Mirai outside when I walked in. That's a Honda Clarity, and that's me refueling it at a hydrogen power station, hydrogen refueling station. They have those in Japan. And that's an artist drawing. Everything I've shown you till now has been real. That's an artist drawing of a ship that's likely to be launched later this year in San Francisco as a hydrogen-powered ferry. It's happening. There's a lot of discussion about, for our homes, for our shops, for our buildings, replacing the natural gas that is used for heating with hydrogen. And it turns out it's quite plausible to do that. And there are demonstration programs already underway in Adelaide and Sydney, so South Australia and New South Wales, to do this for several hundred houses at a time. All of this is an opportunity for Australia, whichever the mechanism is. We've got lots of solar, wind and land. Solar and wind without land doesn't work. Land without solar and wind doesn't work, but that combination is great. And we've got lots of natural gas and we've got lots of coal. And we can support different modalities of making hydrogen because beyond production, you've got to deal with the infrastructure, the piping and the refueling stations and the ports. So all of those will build the critical mass for us to build an industry. But other people get it too. Other people get it too. It's competitive, highly competitive. So on the fossil fuel pathway, I've got Russia, Norway and Qatar there. They're all actively looking at becoming suppliers of hydrogen. On the solar pathway, I've written down Algeria, Morocco, Saudi Arabia. You could add to that Qatar and Dubai. Those countries really see Europe as their customer destination. For Australia, of course, it's Asia and North Asia that would be our most likely customers. So 3 challenges, just to recap. I've talked about scale, I've talked about diversity, and I've talked about competition. And you can see all 3 of them as scary. If you're a glass half empty sort of person, you can see all 3 of those as opportunity if you're a glass half full kind of person. Last thing, I want to take you through just a quick update on the National Hydrogen Strategy. So in December of last year, all of the energy ministers, that's the state energy ministers, the territory energy ministers and the Commonwealth energy minister, invited me to lead a process of developing a national hydrogen strategy. And we've been asked to do that and deliver it by the end of this year, in December. We've got 5 major themes or streams that we're looking at. Export, I've talked about gas networks, I mentioned heating buildings with hydrogen instead of natural gas. Transport, I won't go through the next one, but the electrolytic manufacture or production of hydrogen can help to stabilise our national electricity grid. And industrial uses, again, I haven't talked about that, but that's an important use domestically and internationally, for example, in making steel. And there are a lot of cross-cutting issues, standards, safety, environment, governance, etc. We're looking at it all. It's a big project, a lot of people working on it. In March of this year, we put out a discussion paper. We've got about 120 responses, really thoughtful responses. We worked with that, and then in July of this year, we put out a massive suite of 9 issues papers, and we gave people 4 weeks to respond to that. We got 70 responses, some of them like 30-page reports that I'm thinking about just handing that in instead of our report because they were so thoughtful in terms of their responses to our issues papers questions. So we've got a lot of material, closed that on 28th of July. Now we're on the home straight. We've got till now to the December to draft the document, test it in principle with ministers and secretaries of department because we want to deliver something that they want rather than something that they get a surprise from. No surprises is a good principle to operate on. What we're going to come up with is really a framework. It's really very difficult to say, listen, government, you should start a new industry in making hydrogen cars, or you should export 2 million tonnes of hydrogen in the next 10 years. We don't know what the international demand is guaranteed to be. We're not going to start up a brand new industry just to give an opportunity to hydrogen production. We want to create a framework that makes it easy for companies, states and territories working individually or as consortia. We want that framework to make sure there are no barriers due to inappropriate standards or illegality of shipping across state borders, etc. We want to create a framework to make it easy for companies and states to invest in a way that is safe, cost-effective, and really importantly, we want to avoid pitfalls, which would mean that the benefits go to the few instead of to all Australians. And I believe that if we can get it right, we will be able to see our planet in the future and it will still be magnificent. Thank you.